So let's start this. I want to welcome you first to MySQL User Conference. I guess the formal welcome is tomorrow, but since this is probably the first thing you see, so I would like to welcome you all. And I think it's great that you come to the replication tutorial. I'm Lars Connon, and I'm leading replication, backend, and engine technology. And I started at Ericsson like 7 years ago, and then MySQL bought the cluster technology from Ericsson. And this was 5 years ago. So I've been working with MySQL related stuff for maybe 7 or 8 years. And first I moved from the cluster technology into replication. I worked with that, and then after a while I started out the backup project, and now I also have the engine group. And
I'm Mats Kindal. The full name so you can have pronounce. I'm the lead developer for the replication team. And I try to see where I can use replication to. So I'm trying to get replication to work in a good way. In my background history, I started working for MySQL in 2005, I think. This guy called me, asked me if I wanted a job, interesting job, and I asked him. That's the way it went. In my previous history, I researched distributed systems. I was researching distributed systems, and I also worked with implementing compilers distributed systems.
So can you hear us well, both of us, or Mats needs to speak up a little bit more, or?
I need to speak louder. Is that better?
So let's start with the concepts, or maybe we should first talk about the booklet you have. So you can.
Yeah. You have gotten a small paper. If anybody hasn't got the paper, you can ask Chuck down there. He has got a bunch of them. This is something for you to put in home, because the only way to learn replication in a good way is to play with it, experiment with it. And this is instructions to some small utility script so you can set up replication on your machine. And it doesn't matter if you have a server installed already or something else. You can start as many slaves, masters, whatever you like, and then you can play around with it. So it's an easy way to set up the replication, any replication topology. And you have basic instructions here, and something to bring home, play around with. If you have questions, you can mail me. If you have suggestions for improvement, you can also mail me. You have my email address on the document.
So the idea is that we give you all the information here, and you know how to do everything, and then you also have the possibility to do this stuff using this booklet. So let's start with MySQL replication and what is it about? Why do people use MySQL replication? So I would say there are 3 reasons why people use MySQL replication at all, or replication at all. And the first one is for high availability. So you get a redundant copy. You get a copy of the information somewhere else. So if your first database fails, then you have the information at a different location. So that's for redundancy, it's to get high availability, because you can switch over the client to the other one if the first one would go. So the second reason why I use replication is to use it for load balancing, or to scale out. So you have one server, and you can service a certain number of clients and a certain number of queries on the server. But after a while, this server gets bogged down because you have too much load on it. So what you can do is that you can introduce other servers, and you replicate to these other servers, and then you can service much more queries this way. And the third one is like off-site processing. So you have some server, and a database server, and you're very careful about this data. And you don't want to disturb the processing on this. So what you do is that you replicate from this server to another server, and then you do the analyzing of the data, or you do backups, or you do these operations on the other server instead of doing it on the primary server. So it's just being a bit careful to not touch this, especially if you want to do analyzing of the data that takes resources to do. So how do we do replication? We do it via first we need to have some kind of snapshot. So replication replicates the changes. But if the original database, which we call the master, if the master has some data already, then you somehow need to get this data over. So you do some kind of backup of this data, you put it on the slave, which is the destination of the replication, and then you start replicating. So you have some initial snapshot on the slave, and then you start replication to replicate the rest of it. And for that, you can use a program called MySQL dump to dump the data from the master, and then you can put this on the slave. And there is also other techniques. NDB has a so NDB is the MySQL cluster. So MySQL cluster has a hot backup. DB has a hot backup solution. And we're also developing new backup solutions for MySQL. And this will be a separate talk by Chuck, who's in another room. Using this, you can also set up slaves. And this new backup development that happens in 6.0. It's a little bit in the future. And the main tool we use for replication is the binary log. So we make a kind of log on the master, and the log is shipped over to the slave. So replication is asynchronously pushing this information to the slave. So to mention a few things about synchronous and asynchronous replication. A synchronous replication is when you put something on the master, and you don't allow it to be committed until it has been replicated. So you're always sure that the information is in two places. But this is not what we have. So what we have is an asynchronous solution. We want the replication to be as fast as possible, and we want the processing on the master to be as fast as possible. So we allow commits on the master, even though it has not been replicated yet. It's in transit to be replicated. So this is asynchronous replication. We go into this a bit more in the future, in this talk also. And this binary log can also be used for point-in-time recovery. So we can use a backup, and then we can apply the binary log to go into the point in the future.
Yeah, the basic terminology we have a master, which contains only the basic changes and makes it go to master. And then we have a slave, which actually just accepts the replication stream and applies those changes in order to get to the same point, same data as the master. The important thing, the communication channel between the master and the slave is the binary log. Every change being written or being done on the master is actually written to a separate file called the binary log. That binary log is then sent over to the slave, and the slave applies. You can use this in various ways. You can start replication and just keep it running. It means it will wait until you get a change on the master, it will go over to the slave and it will apply that. You can also, if you have an old binary log, you have a saved binary log, you can tell the slave to apply everything up to this point in the binary log. That allows you to do a point-in-time recovery. So you can recover the database to an exact point in time, an exact transaction or exact date that you have connected to binary log. This means that you can, for instance, if you have a running master, you can connect the slave at any time. If you have a long binary but it will eventually do that. So the binary log is also a history of every change done on a master, and can be used for auditing or keeping track of other things that has happened on the master.
So the picture is quite simple. We have two processes, and we ship over the changes from one process to the other process. And the changes are stored as a log. Are there any questions so far? Let's take a few questions just to... Yep?
You don't present binary data or any kind of thing, but this replication tutorial is about sending data directly from the master to the slave in order to keep the slave up to date. If the master goes down and you start using the slave, are you going to talk about the high availability model as far as like how that's works?
Yes, we will go through the first on how to configure it and how we set it up and how to manage it, and then we will also go into different scenarios and how you can use a slave when the master is going down. So we're coming into there's different scenarios. This is the simplest way to use replication, but we will also go into more complex scenarios. Yes?
For using this for load balancing, I see how changes go from master to slave, and there are changes going from slave to master.
We can do, so we go one direction like this, but there's also more complex scenarios where you replicate in the other direction also. And you can replicate to many of these. So we will see these scenarios also. So here is a little bit more about the synchronous and asynchronous replication. So that it's pretty important to know these concepts, I would say, so that one knows that the replication in MySQL is asynchronous. So the asynchronous is what we have. So synchronous one is when the transaction is not committed until the data has been replicated. Sometimes one requires that it should be applied also, but at least replicated over to the state. And this is safer, but it's slower. Because if you execute the transaction on the master, you have to wait until it's replicated over, and then you get an acknowledgement, and then you confirm that this has been done. So you don't allow transaction to commit until they have been in two places. So this is safer, but slower, but this is available in MySQL cluster. So in MySQL cluster, you have synchronous replication built in. In the asynchronous replication, you replicated the transaction after it has been committed. So this is faster, but you can, in some cases, you can lose transaction if the master fails. In practice, the replication is so fast, so usually you have the data already on the slave. But there are situations where you can lose information if the master will crash. And this is easy to set up with the MySQL.
So, when you set up replications, really not very difficult. There are a few things you have to think about. First, you have to configure the master to work as a master, and you have to configure the slave to work as a slave. To configure the master to work as a master, you have to have a binary log, and that is critical. If you don't have a slave to write or change it, you can't work it. You turn this on by using the log bin option in the configuration file. Usually it is a good idea there is a default for this one, which is based on a name actually. So you get a default binary log, but don't rely on that one. Give the binary log a distinctive name so that you can separate it from other binary logs. So if you start replicate and you have one slave, trust me, you will get more in due time. And then you have to keep binary logs separate. So don't put the default for the login option and use it to get binary log. The second thing you need to do is you need to identify the different servers. So you have master server, you have slave server. Now if you have a dual master setup, that replicates to each other. The roles of being a master and the slave is kind of blurred, but you need to have a distinctive server ID for each server. So you have to have a server 1, a server 2, a server 3, and so on. If you have the same number assigned to 2 servers, and you try to replicate from a master with the same server ID, it will tell you that this might not be a correct configuration. But if you have slaves in between, that means that any evidence coming from the first server 1 going to server 2, going to the second server 1, the second server 1 will assume that those evidence being applied on the first server is actually what he did himself. So he will ignore it. You have to administer the server ID yourself. So we have to make sure to set the distinctive server ID for each server. And that is not something that replication does, or the configuration does. You have to put a number there. The second thing you have to do for the replication slave, you need a server ID. But that's all. Now, if you want to log changes on the slave as well, which might be a good idea, you have to have a login option there as well. But we'll get more into that later. There are a few other things you can do. Normally you can configure most of the slave and the general replication by just using command from inside SQL, inside the client, because you can configure most things there. But there are a few things you can't configure from inside the running server right now. And that is when you do filtering. You can filter elements based on database, and you can filter elements based on tables. So that you can have a master that only sends a certain changes to a certain database, or ignores changes to a certain database, so that keeps it inside. On the slave, you can actually do the same thing, but you filter when you have received something. So if the master sends changes for a database, and the slave receives all the changes, but decides that I don't need these changes for this database, then it can ignore them. You can also, on the slave, you can filter based on a table. So based on what table you are actually modifying, you can actually filter out changes done to that table. But that only works on the slave, not on the master. You can't filter by table on the master with traditional MySQL replication. This is something we're working on. We have some ideas. So if you're interested, I suggest you join the further section for replication. But right now you cannot really replicate based on the table on master. You have to do that on the slave. And you have two ways to filter actually. You have an explicit table and you have a while table. A while table means replicate based on while format. So you can say all tables starting with A, all tables starting with ending with A. So that gives you an option to actually say what to replicate and what to apply on the screen.
For ignoring the table, that's supported in 4 or MySQL 5?
I think it's supported in at least 4 of them. Maybe not 4 of 0, but I'm not actually entirely sure on that. But it's 4 ones at least.
Just give a comment on what you said also about the Bergen method. So in this tutorial we go through the things which are implemented now in 5.1 and downwards. But then we have also replication tricks and tips, which is tomorrow in the afternoon. And then we go through a little bit more of the future, what's happening, and feature previews we're showing. And so these things, for instance, we have solution with scripting and stuff, which we are implementing now. So that's the future. And there is also tomorrow evening there's a replication block where we also report about what's the future of replication.
And where you can ask questions if you have something specific for one replication.
So there's more optional configuration that we can do on the slave. You can say that it should be read-only, so that you cannot modify the slave, and that's pretty useful when you are maintaining it, when you're changing something. You can say load slave updates. That means that the things which come in for replication are also logged in the slave's binary log. which means that you can chain replication. So you replicate from server A to server B to server C, and so on. And then you need to turn this on. And then you can instruct when the server is restarted. It usually starts in the configuration that it is in, or the setup it is in. So if it is doing replication, it will continue doing replication. But if you start the slave and you don't want to start replication, then you can indicate that you don't want this replication to start. Maybe you want to check something or debug something, or you want to skip. In the replication, you can also look at the events, the changes coming in, and you don't want to replicate some of them for some reason.
So if I have, say, 3 servers and A and B are master replicating, does the long slave updates, that can cause problems on the master? That third one is going to be the slave name on it.
So if you have, let's say you have 2 servers, and they replicate to each other. So one could think that you create something, and then it goes to this one, and then it goes to this one, and it goes around forever. And the thing which is implemented to solve this problem is that it recognizes when the server ID is the same. So the guy who created this from the start, his server ID is put into the changes in the log, and when it goes back and he realizes that he gets an event which has the same server ID as himself, then he will just go away and he will not do it. So you can have 2 servers that replicate to each other, and then replicate also from one to some other.
A short comment on that. I think you asked about or slightly different. If you have 2 masters and you don't have a log slave update on, that means that the changes go from that master to that master. But if you connect a slave graph, then the slave will only see the changes made on the first master, the master is connected to, and not the other master. So in order to get the changes done on that master, to that master, to a slave, you need to have log slave updates. Otherwise, the slave won't see the change.
Now you got 2 answers to the question. What's one of them?
That's what I already have it set up that way.
Okay.
And I was worried that there might be form issues like trying to the long slave update server setting it back to the master.
It can actually use. You can skip the log slave update. If you only want to do a master, but you don't do it there, you only connect client keys if you want it there. And you can actually skip the log slave update. And you'll probably be flushing or because you don't have to update the final log from the server. So it might be a good idea sometimes. But usually you need the log slave update, even if you will not do that.
So except for writing this configuration file for the 2 servers, let's stick to the simple scenario now to start with. So you have a master and a slave. So you write the configuration file for each, and that was what we just discussed. And then you also need to grant the permissions for the slave to this user, so that the slave can connect to the master.
On that, you need to have, when you replicate, the slave connects to the master as if it were a normal client. And it has a special set of commands you can send to the master to actually connect. But one of the things it needs is the user to log in. For that purpose, you need to have a replication user on the master. You can actually use any user, it doesn't matter. You have to have replication slave privileges on the user, but you can actually use any user. But it is a good idea to take a dedicated user, because somebody who's replicating the master can see everything the master does. Which means that you don't want to have any other user having that privilege. See, having a replication slave privileges is not worse, but you have more power than if you're user. So be very careful about granting replication slave privileges to anybody except the replication.
So to deploy your application, the first step is to make a backup of the master, so you have something to start the slave from. And there is either you do there's hot versions and there is non-hot versions of this online version. And this is some advice for the configuration.
Well, yeah, this is just how we do it. If you had a running master and you want to start replication from it, first create all the links, receive all the grounds, shut down the master, add all the links to my CNF file, add a server ID if you don't have one. Take it back up, start the master, and then you can use it back up to go out of the place and start replication. Please do not put, it is possible to put the master host and all the configuration options inside the place, inside the place configuration file. Don't do that. Those are available from the command line, so you can configure it online. So if you write it in the configuration file, then you need to shut down your slave server every time you make a change. And that is bad. If you don't do that, then you can change things on the fly when you have a running state. So you don't have to worry about fixing things in the configuration file. So avoid putting things in the configuration file unless it's something that you really know won't ever change. The server ID is not an option, but you usually don't change server ID for because that's usually a subtle problem.
So these configuration options like master host, master password, and there's a lot of this configuration. I think there's 9 of them, configuration options. And up to version 5.1, it's possible to use this in the configuration file. But in 6.0, we have removed them. So it's a good way to not use it. And what you do instead is that you use the change master command to set it. We will go through that.
If you have a binary log running, then you can always do this by doing slot tables with relog. That will keep the database temporarily. Slot tables keep the database temporarily, no changes can be made. And you can do show master tables to get the binary log position. And then you can unlock the table, start master again. So you can start the brief moment. Once you have that, you can take it back up of an existing place. You have to have it in an existing place. You don't want to stop something. And then you can go back. But this is not what you want.
Well, my question is, you not have a free record form. And I want to start a new replication data and
You need to get it back up. You can do that. If you want to do a physical backup, yes, you have to take the master down. There are, however, online backup tools. So you can use MySQL down. You can have an TV table. You can use MySQL down to get a snapshot of the table set. Or if you are using a default backup, you can also get an online backup. But in general, if you have a master, you don't have any special backup tools, you have to get it down. Or use MySQL down. But MySQL down will give you a sequence of statements to execute, and it will take time to configure it. But it is possible.
Well, it depends on the storage engine you use, which is a host backup. And for InnoDB, for instance, there is such a tool. So it's possible to use MySQL down. Restore the backup onto the slave. So we did a backup on the master, and before we start the replicate, we apply this backup on the slave, so we have an initial snapshot on the slave. And then we configure the slave. So the slave that connects to the master as a client. So you do most of the commands you do on the slave. you instruct the slave how it should replicate from the master. So on the slave, you do this command here. So you say change master to, this is the name of the master, of the host, and this is of the user, and then the password. So then the slave knows about its master. So this is a kind of configuration, but you do this configuration as a SQL statement.
And just to continue to have super privileges. So you have to be super privileged.
Is that master host the host name or is it the server?
No, this is the computer host name. And it's the IP number you can start with as well. And this is a different version of this, and in this one you have the host name, and then you say that you want to start in a certain binlog position. So you can instruct replication that you want to start in a certain position on this log. For instance, if you want to skip something, or if you have recorded, if you have done a backup of your master first, and you recorded the binlog position that corresponds to this backup, then you want to start replication from this position. So you want to start the replication from the position that corresponds to the backup, so that the replication will continue from the backup time. And then what you do is that you say start slave, and then it starts the replication. So there's a few things you put into the configuration file. You do change master command on the slave, and then you do start slave, and then you're off and running. So replication topologies. So you can replicate in different versions. So far we mostly discussed the simple one where you have a master and you have a slave. But you can also have other topologies which are more complex. So this was the simple one. And in this simple one, the master creates this binary log. And the slave makes normally a TCP connection and then gets the binary log. So the binary log is given to the slave and it's being applied to the slave. So replication is independent of the storage engines. So you can replicate between different kind of storage engines. So you have some tables and you store them in MySQL, and then you want them to be replicated and they should be put into InnoDB tables. So what you can do is that you can create these tables on the slave and then start replication after the creation of these tables and then replicate the changes into this. So on the master you have some type of tables and on the slave you have other types of tables.
Comment on that, you can replicate from any storage engine, of course, but it's not necessarily possible to replicate automatically from transactional to non-transactional. So you might have some surprises. It will work, but if you are trying to do rollbacks or stuff on the slave, for instance, if you have a transactional table on the slave, but a non-transactional on the master, and you get rollbacks on the slave, then you might have some surprises. So, think an extra task. You can use any storage engine, but it might not work exactly as it is. The safe bet is to always have the same storage engine on the master and the slave, but if you have a special need for it, you can switch engine on the slave. You can also switch by using all the tables, whatever engine equals minus. You can switch on the time.
Yes, I agree on that. So normally this would be if one wants to do something in particular, and then one needs to investigate more how it exactly should work. So another topology is the master with many slaves. So this is very common. You have one master where you put orders. So if this is a web store and people order different things, you will put the orders in here. So you write stuff here. and you add new products, you add it here. But on the slaves here, often you read information. So you can have a lot of users who serve to your web store, and they look for different things to buy, and all of these reads go to the slaves. So then you can serve it very quickly, and then the few, or hopefully your web store will be very successful, so it will be many people, but the fewer people that actually buy something, they put the right request in the master. And you can also chain it, so you replicate from the master to a slave. And on this slave, you say load slave update, so that the changes from here go into the binary log of this guy. And then you can put another slave here, which replicates from this. So you can build, not only can you build this simple tree structure, but you can actually build it in several layers as well. So then there's different problems. If the main one, if the middle one goes down, then I wonder if this is by missing in this.
No. If the middle one goes down, we actually have a problem because these are all different. They are both running, but they are all. So we have to synchronize them. And that is not always straightforward because we have to somehow figure out what the change is done on the slave actually corresponds to an master. So we have to go look into the replication class on the middle server. You have information in the middle server about how far it got before it crashed. You have to go look up those files, actually see what positions you have there, figure out what the position is on the master, so you can actually save the master. So it's not straightforward actually to use the chain master chain code because it's difficult if the middle master goes down. So you have to think about this before it happens and have it done before actually connecting the save the master. And I strongly advise to automate this somehow with the other thing is to detect that the middle has gone down and you can redirect it to the main master.
So there's many people who have like using Linux heartbeats or something and check that if the server is still alive, and then when you change how this is being replicated, then you need to find the right positions and do some script for it. Okay, so each server should have a unique server identity so we can distinguish them. And so in this example, we just have put different numbers on them. And every event in the binary contains this server ID. So we can look at the changes which are being replicated, and we can see who created this one from the start. So another possibility is to replicate in a circle, but here it's a little bit tricky if one goes down, because you get several problems actually. Because if you So it's okay, as long as you don't want to fail over, replicating in a circle works fine. But when you want to fail, so if one circle goes down, what one often wants to do is just make a smaller circle, replicate that. And that is the tricky. So often you can make a different configuration to solve your problems. There is often some other solution to do it than you to use the circles.
The problems we have with replicating in a ring goes down is basically the first one is reconnecting the existing slave to the good position, the right position of the existing master. And the other problem is actually if you have some changes being made to this master, they have been shipped off, and that one goes down. What then happens is these elements go here, they have a server ID 3, I think. They go there. And then when you have set up the ring again, they go there again. And since the server only removes edges originating from itself, it means we have all the edges that this master generated, that we managed to take away from the replication screen, will continue circulating forever in this
So one can have pair masters and they replicate each other. And there's different ways you can do this, but you should often take care so that you don't update the same row here and here. So if you have clients connected to both of them, and you update and you set one row to let's say number 3, and the other one you set to number 4, and since replication is asynchronous, it will ship it. And if you ship it in exactly the same moment in one direction and the other direction, you put the 3 in here and the 4 in here, the 4 goes over there, the 3 goes over here, so you actually have different data. So so when you use something like this, you need to figure out what you actually want to accomplish. So it's not as easy as just taking 2, replicate each other, and just start to do things. Because since the asynchronous replication, you can do the same. You can do different changes of same data, and they will make these 2 diverge. So they will have different data.
Short comment on this. There are basically 2 scenarios where you want to have a real master setup. The first one is to actually have a passive standby. So you can make all the changes to one master all the time. So all writes go here. So if you keep this one around, just to make sure that you have a hot standby. The other scenario is trying to scale out writes. So that is tricky. And that means you have changes coming to both masters at the same time. And there you have to be careful. So when you try to use this setup to scale out writes, be careful. For the passive standby, it's not a big deal. It's not a big problem. Usually that means that all changes go here all the time, and then suddenly this master fails, you go to that one, you keep running, then you bring that one up. And then you have this screen is normally not active, but when you bring up the master, it starts reading the data because every change runs every step. It catches up, and eventually you're back online. And you have to do action on. So that's the entire purpose of having a real master.
So the 2 most common question.
I'm sorry, I just wondered if you were going to get into some of the challenges in balancing out those rights across 2 active masters. Can you cover that maybe later?
Balancing the rights for the master? No, we're not going to cover that. It's more, you have to use a smart line like MySQL proxy to balance the rights in this one. So if you want to do roll balancing, you can use MySQL proxy.
Yeah, I just wanted to point out, you use the phrase to scale out writes, but writing to both masters doesn't actually scale them at all.
Right.
Because you're still limited to the number of writes you can push through one server, since they have to keep up with each other in replication.
Yeah.
Right. So we shouldn't use the term write scale out. So the problem is that if you have data in 2 different places, if you write to one, you will replicate it over to the other one anyway. So it will write to both. So you don't really gain by having 2 servers. The number of writes to each server will be the same. So you cannot scale out writes if you have the same data on both servers. So if you have one server and you do 10 updates, if you take 2 servers and you do the same 10 updates on both of them divided, but you replicate, the number of updates on each server will still be 10. So it doesn't make your servers better. So if you want to scale out writes, you have to somehow partition the data. So you put some data on one server, some data on one server, and to do this, you need to do something smart, often in the client, in the application, to figure out how you can use these different shards of data, partition this. There's also, if you want to scale out writes, you can also use MySQL cluster, because in the cluster you are partitioning inside it, so it will put it into different places. So you can start looking into that also, scale out writes. So the two most common topologies for MySQL replication is that you have one master, you have multiple slaves, and you often do the reads on the slaves. And this scenario, one of them would be inactive usually, so that you can have it carry over to. So you would use one actively and do the changes, and then this one would be passive, but you will have all the data. So if this one fails, then you can fail over to this one. So,
well, here we have a relay slave with many slaves, so we want to scale on. And the reason why you pick something like this is because if we start adding slaves to the main master, after a while it will start to show as well because it has to clear all the changes. So in that case, we can actually replicate all the changes with a slave that whose only purpose is to distribute the job to other slaves. So you have to release the master some of the work to be able to distribute technology. So we have dedicated slaves for distributing the work. And in that case, you of course need to have all the updates on, as we previously mentioned. Otherwise, the changes on the master will not go to the slave, they will stay there. But there's a problem with this one. I think it's on the next one. Right. If this one goes down, what happens then? You have to redirect all the slaves to either the master or a backup master, which can be a considerable amount of work. So make sure this one is running somehow, and do it in several ways. You have to think about this beforehand, because you don't gain, when you have a failure, you have to redirect these slaves, so you have to manage them somehow. The trick here now is, if you have a relay slave, and you get changes from the master to the relay slave, then they are all saved to disk, and after a while, the disk will start to fill up, which is not a very good idea. What you do instead is actually have something called a black hole engine, and the black hole engine, it doesn't write anything. It doesn't have any tables. It's only there to allow you to chain replication to other slaves. So changes on the master go to the slave. The slave applies all the changes to the black hole table, which effectively doesn't do anything. And then it replicates the statement for the row further on to the slave. That means you have a relay slave where you don't have a lot of tables, you have non-tables, actually you have no memory for the tables at all. But you still get it to replicate as if you had tables there.
Question?
Is it taking some checkpoints on this so that that box comes down and comes back up? It knows where it is and
Yes. Replication is always, you keep track of replication progress all the time. You don't keep track of whether it's on every master or
So these are the replication commands. We run through them. We have show master status. So this is run on the master, and you need to have some privileges. And what this does is that it shows the position of the binlog for the master, so you can see how far the binlog is. So in this case, this is the latest file. This is the position, and here is a filter saying that only this database should be put into the binlog, and these two databases should not be put into the binlog. And normally I would say that people put everything into the binlog. Yes, there's a in the manual there's a set of rules. Which one takes precedence over the other one? So you can follow these rules. And the do DB is stronger than the ignore one. So if you specify it on both, I think the do one succeeds.
Yeah, but does it do any other databases that are MongoDB test? Other databases on server replicate?
This is kind of an artificial output. Normally you only have either UDB or you don't have both. So if you have UDB, then you replicate that table only. If you have more DB, then you replicate every table except you have. But if you have UDB, if you have those, then UDB is what counts.
So you can do show binary logs, and this will display the list of the binary logs that you have on the master. So you can use this before you use purge binary logs, for instance. So purge binary logs will remove binary logs from the master. And when you remove logs from the master, you also want to check all the slaves if they have actually replicated enough of the information. So you don't remove something from the master bin log which needs to be which replication needs to replicate the slave. Show bin log events is a command to get the contents of the binary log. So you get the different changes. So in this example, you show the binary the bin log events from this file position. So each file belonging to the binary log is indexed by the byte position. So this is the byte number 390. And then you put this command outputs just one of the events. And this is a query event, and in this case it does create a table. So this is a way that you can analyze the bin log on the master, or the slave if you have bin log enabled that too. There's a better tool, in my opinion, and that's the MySQL binlog tool, because you have a little bit more options. You can do more things with MySQL binlog. And the MySQL binlog program, you run it on the file directly. So this is something you use on the MySQL client as a MySQL statement, but the MySQL binlog is a program you run.
A full comment on this one actually. One interesting thing to see. In the query log element, you have always the use and run the current database first from the statement. And the reason for this is that if you're replicating something, if you have something like create table, T1, you want to make sure that you are actually creating test.T1 and not something else. This has some interesting consequences. What it uses the current database all the time. That statement goes into there based on the current database, nothing else. So if you have a create table and you have another database, you have test2.T1 instead here, you will still use the current database when you execute this statement. This can have some interesting consequences when you have filter on, for instance. Because filtering is done on the current database and not on the database where the table is. At least in statement-based replication. Role-based replication is different thing, but for statement-based replication, filtering is based on the current database and not on the actual table or database you change. So you can cheat replication and say, hey, I'm using the current database test. And you can write a statement that changes another database, a table in another database. And it will replicate fine, because we filter it, you won't filter that one off. It can be used for good and it can be used for bad.
Then we have show slave hosts, and this you run it on the master, and you can see what slaves are connected. And this one we are actually changing, so it might not be the best thing to. What it does then, it only shows the ones that are currently registered with the master. So often it's a better way to use another command on this. We'll have another way to know what slaves are replicated. For instance, ask the slaves if they're replicated. So you can purge the binary logs on the master, and so this removes all log files before a certain file or date. So you remove the old ones. And you need to make sure that the slaves have replicated enough information. You can set if something should be logged to the binary log or not. So you have a variable which you can set, and you can say that I don't want these queries to be logged at all. So they will not be part of the binary log. So in this example, this statement here, it will not be logged.
A short one on that one. This script does not work for any use. And the reason is NDB takes care of replicating their own code and don't care about that very much. Or rather, don't care about the very much the way they should. You have a question?
Is that based on the user you're currently logged in on, or is that binary logging in general for anyone else in the
Binary logging is always on a perception basis. So this is a secondary place for the actual connected code.
Then you can say when the binary log is expired, so you can set this variable so that it automatically purchases log. A rested master, so this one will delete all the binary logs in the index file. So this is quite a strong statement. It's quite destructive. So it deletes all the binary logs that exist in the index file. So all the binary log is also an index file, keeping track of what files belong to the binary log. And also it rests the index itself, and this can be used to get a clean start from the master. But it removes all the logs.
How would you like to use this one? There are actually two good setups where you can use the master. And suppose that you are setting up all your servers first by assigning users, you're creating users, and you are running the services and that kind of stuff. If you have different users on different servers, you don't want that replicated. So in that case, you can actually turn on the binary log, or you can actually do your changes with no slaves running to the master, and then you can reset the master to make sure that it starts from scratch. Everything you did before this point where you just configured stuff will be removed from the binary log. So it can be useful in some cases when you do configuration first on separate servers, and then you reset the master to make sure that now I'm ready to start with it.
Show slave status is to get the information about the slave, and normally the slave has most of the information about replication. So it shows, for instance, what slave threads are running. And slave threads, you have one thread which is getting the information from the master, and that's called the IO thread. So the IO thread is the one connected to the master. And then you have an SQL thread, and the SQL thread is applying the stuff on the slave. So there's one thread responsible for the transmission or receiving it, and there's another thread which is responsible for applying the information. And here you can see what are the last thing which was replicated over from the master to the slave, and you can also see what was the last thing that was actually applied on the slave. And if there are any error message, then you can see this by using this command as well. So this is an example of an output.
Worth noting here is these error messages, these fields are added in 5.1, they did exist before. Previously we had now let's see if I can find it. We had lost error and lost error there. Failure for error number and error for the SQL thread only. But we added 4 fields, so you can see if we have a failure on the item thread, you can get the error message. This means that lost SQL error and lost error not. These 2 fields are the same as these, show the same values all the time. But for To have consistency, we added these 4 fields. You can see both the IO thread status and SQL thread status.
And the most important things are maybe, what is the connection you have to the master? What is your master? And how far have we replicated from the master? And how much have you applied on the slave? And in this case, we see also that the slave is not actually running, the replication is not running. It's not reading from the master, and it's not applying stuff on the slave. And then we have the filtering things for replication. We have if they should skip to do something. So you can instruct the slave that we should skip 5 events if you don't return some events. Give information about the log. You can replicate until a certain position. So you tell it, I want to replicate until this date. So it will do it this way. And also you can have a SSL connection. Use that. And this indicates how far you are running the application. And then the main command is the change master and then the start slave. So change master, you execute something like this. And start slave, stop slave. And you can also do some variants, so you don't start both threads. Normally when you do start slave, you start both threads, but you can also select that you want to start one.
When do you do that?
Maybe you want to replicate everything over to the slave, so you have it in, then you will have it in the so-called relay log. So it's like a buffer on disk for all the changes, but you don't want to apply it. So you want to make sure that you have all the data on the server, but you don't want to apply it. Maybe you want the slave to be half an hour bit behind the master, so you can see if there's any mistakes. But most commonly, of course, people do it without both of the threads.
The first one is going to go likely to a master slave resolve, or the second one is actually applied to the slave.
So the start slave SQL thread. So if the SQL thread is running, it will read from the relay log and apply it. Yes. So the SQL thread is local to the slave. It doesn't know anything about the master. It just takes the thing from the relay log and applies it. The IO thread is the one which is getting the information from the master. So IO thread is the receiver, and SQL thread is the applier.
So I want the 30 minutes latency in my IO thread, but it's not within the thread.
Yes. And then you need to have a script which checks how far you are, and then you need to turn on the SQL thread and have those things as well.
If you do just like the MySQL binlog, is that apply it? You ran the
So the MySQL binlog program can take a binary file and it can output SQL, and this SQL you can apply on any server. So that is not really, in a way, MySQL binlog is not really related to replication, because you can just get SQL from a binary log, and you can apply it to the same server or another server or whatever. But I didn't get a question anyway.
Yeah, there's one thing, the IO thread won't write to the binlog. It didn't know the way.
The IO thread is writing to the relay log, yes. So the IO thread is... Yes, you can use the MySQL binlog program on the relay log and check the status of that one. Yes.
If you are master, if you master replicate, what is the master? Do you start the slave or start master?
No, you do the same thing. It's always the slave that is in control over the replication. It's always the slave that decides I want to replicate or I don't want to replicate. and it makes a connection to a master. So if you have a master-master connection, they will both be slave to the other. So you need to go to both of them, and you do change master, and then you work that guy, and say like, set it up for this, and then you do start slave, and then you start replicating this way. And then you go to the other guy, and you do change master, and then start slave. So the dual master setup is just replication done twice. It's nothing more. Yes?
Replication latency, there are two things information I need to know. Is what is my current replication latency? And the second one is how long does it take to catch up the replication latency? How do I get this to these things?
Okay, so one thing is that you can look at the binary log of a master, and you can see what was the latest time something was written into it.
I think I can answer that one. In show status, you have something called seconds behind master. Yeah, but that is kind of tricky because it's the difference between the actual time you finish executing a statement compared to when it was executed on the master. So it doesn't really give you any information on how a precision measure of how long it will take to apply the remaining. Well, it just gives a rough estimate of how far behind you are.
Much of this application orders.
Yeah.
If I have a replication latency, then my manager needs to know what is the actual replication latency, especially after each moment.
Yeah.
But before that.
It's not that easy to know because we execute statements in both master and slave. The seconds behind master gives an estimate of how far behind you are, assuming that you have the same machine on the master and the slave, you are doing the same things on the master and the slave, which you don't usually do, then this is accurate, because you are doing exactly the same work on both. If you have, for instance, you are loading the slave more, you are doing more on the slave than on the master, then statements will take longer to execute, which means that the seconds behind master is was correct at that time point, but the remaining pieces you have to apply will take longer than it did on the master because you are loading the slave more than the master. And on the opposite way, if you are loading the master more than the slave, then the slave will catch up faster. So the master, the seconds behind master might not be an accurate estimate of the actual time that the slave is behind. But it's a rough estimate. It's the best guess.
What's the best way to know what is how many transactions waiting for the slave to apply?
Currently, it's not possible to get that kind of information except with guessing.
What you can do is that you can look at the log files, and you can use some script to figure out how much is in there. So if you check the relay log and you see that there is 5,000 events in this relay log, then you can also see time of the events in the relay log. You can analyze the relay logs and you can check the time points in the relay log and figure things out. And you can also, you need to compare the position that was, so you have one position which is what was last applied. You have one position which was last read from the master. And then you can look at the relay log, and that's the difference between these two positions. And then you can also check in the binary log and see if you are behind that too. So there's two ways you can be. If you use the MySQL binlog program, and then yes, then there are different flags to get information.
What you could do is something like this. You use those statements, get the position of the relay log and the position of the binary log. Then you use MySQL binlog to actually get a dump of all the statements in the system. After that, you have to use some text matching to actually see how many transactions you have there. So normally, if you have 20 events, begin is an event, commit is an event, which means that you can have each transaction can be several events. But you also have for non-transactional tables or simple DDL queries, you just write a statement, and that is is a transaction in itself. So you can get all the statements between the 2 points, all the statements that remain to apply, but then you have to do some intelligent scanning of the file to actually figure out how many transactions you have. It's possible, but it requires specialized skills.
So you can use the show slave status to get these positions. When you check for these positions, then using the two tools you will use is show slave status and MySQL Replication program, and then you can check positions, and then you can check the sizes. And then you have a rested slave, so you can rest the slave, and this will delete the master info and relay log info file. And the master info keeps track of how much have we received from the master. So the master info file is the closest one, and that's the one that the IO thread uses. So the master info has information about what it has received from the master. And the relay log info has information about what has been applied on the slave. So this one is owned by the SQL thread, and this is owned by the time thread. And relay logs are removed automatically. So when the slave is applying stuff, it removes the relay log. So that has an automatic purging mechanism. So if the slave is up to date, then you don't have a relay log.
You have to figure it. So if you want to keep the relay log, instead you keep the relay log.
Yes.
One thing that is worth mentioning here, when you do this, think of it. The reason is we remove all replication information, but you don't remove any data in the database. So if you are resetting the slate and starting the slate again, you will get all the changes you did from the master a second time, which gives you very likely class of data, primary keys, subsequent keys, can cause the slate to actually file. So when you do something like this, think of it before the data on the replication information will be removed, but not the actual data in the database. Yes? I think we can use the address right now. Normally, if you search the binary log, there are two options. You can search by log, or you can search by date. So you can tell if you search every binary log, remove them completely, before a certain date. And that will remove every binary log except the one that contains the data. So it will remove any binary log before. So you have to first figure out what binary log will be searched, to the backup of that, to the backup of your database, perhaps, depends on what you want to do with it, and then you can do it. I think we can use the evidence inside that evidence, which is kind of on the inside MySQL. You can do first binary logs using Chrome, but inside the server you have something called an event scheduler, which you can run on a periodic basis. You can run it once every day, search all binary logs before and out, if you like it. But that create evidence.
So if you have a master slave replication, and you want to make sure that you have the stuff on the slave, I think what I would do is that I would write a script on the outside that would check that the slave is actually up to date first, and then I will do this project. Just as a precaution to check that all the slaves are okay before I delete the binary log. Yes?
A quick question. One of that global variable, the expired log stays,
Yep.
that affects the bin log. What about for if you're on a slave that's also doing that like a master slave, like a chain? How do you use that same variable to affect that?
Yes, you can set that variable on the slave for its bin log. Yes.
So does that affect both?
That would purge the bin log of the slave.
Okay.
So if you want the master bin log to be purged, then you need to do something. Then you have to set it on master. So the bin log is owned by the server who writes it.
Right.
So you can have both. So you need to use this variable on the server.
Quite frankly, I have find that you don't replicate this variable. So it will only affect the I have a short comment as well. With this paper I gave you, I have on we have the tutorial page on the board. There's a small package for scripts and stuff there. I added a small code script to actually take a number of servers and check the binary log position using the tutorial page. You get it out in my request. You can generalize that if you want. I will add, I actually mentioned two other scripts in that document, and I will add that. One script for taking backup of a running script, the other one for actually loading the script, how it's running the script. I will add those two, but I haven't yet. Yeah?
People input tool to compel and pick up more synchronized master and slave table.
How do you mean synchronize?
Synchronize is good expressively, then use the master.
No, we don't have anything like that. I think there are the mock kits. The mock kit is a toolkit for MySQL tool, which is by Bergen, if I remember correctly. He has tools to actually compare two tables and see if they are the same, if they are up to date. You can only get information about where you have discrepancies between the two tables. Mock kit.
It's an open source tools.
Yeah. It's an open source tool. MAA2KIT. It's called with MySQL tools, but there was about trademarks and everything. Yeah, the same thing.
We're working, but it's not even going to be in 6.0, but in later versions it's going to be using online backup, and it's going to ship over stuff, so you will get automatic setup. But that is for 6.1 or something. It's for the future. And if there are problems with replication, you can say that you don't want to execute some events. So you can use this variable and you just say that you want to skip 3 events from the binary log. You don't want to execute them. And this is now fixed so that it rounds up to the whole transaction. So if you skip 3 events and an event is actually 10, the transaction is actually 10 events, then it will round it up to 1 transaction. So this is just to skip some events of the
No, skipping events of the slave. The issue is, say, for example, if I'm using a calling event, my slave is happening of event. After the skip event, is a good idea. If I'm keeping a backup of my
We should have the counting that.
This is if there is something wrong.
Yeah.
Then you can use it.
So if you end up suddenly the slave off with what you can here because somebody added a row to the table, then you can say, okay, I know that one is fine, please get this and then do something.
Some use cases, we already talked about these two. You can have the specialist slaves that these are used for like reporting or analyzing, and this is used for backup. And there is other ones where you can you can have some of the queries go to some slave and some other go to another one. So you set, so it only replicates some of the stuff to these two and only some of the stuff to the other.
This can be very good, for instance, if you know we have a large amount of queries with a message port, you can have many places for that. And then you have few queries with the transcript, for instance, you can have fewer places for that, so you have specialized replications, say scale out place. And you configure that so that you have a good response time for your environment. There's a problem with this actually. The problem is that if you replicate from the master to all these slaves, you keep all the data. Even for on the message board, you keep all the data for the friends. And on the friends, you keep all the data for the messages, which might not be a good idea. In that case, you can actually change on the slave service that serves the messages. You can change the tables that contain the friends list to be a black hole engine. And then you will have routes to the black hole engine and the table going over. And the other way around for the friends list, you have black hole engines for the message board table, and you both change it will disappear, not wasting memory. Yeah? Yeah, you can do that, but this might be worth it in some cases. So this is just another way to do the same thing, but you could use my just one over. So you have to do.
So you have two filters today. So you have one filter which goes before the binary log, and then you won't log it at all, and that can be a little bit. One has to think about if one actually don't want to log everything. And then there's the second filter is when the slave receives stuff, it can throw it away using this replicate to DB and these things. And then it will throw it away, and it will no longer be there. And with the black hole, you will actually get it into the log of the slave if you want to do something with it. So there's a little bit difference on how you use this. So things to think about in the replication. You need the initial snapshot to start them up. Load balancing of clients is also something you can use proxy for. That. So you have all of these slaves that have data, and how you, and it's an application which server you connect to, that you have to figure out in your setup. And then failover of clients to new master. If you want to implement that, then that's also something you have to figure out. So these are the three things one should think about when one is setting up application. So then you have solutions where you can mix so that you have this is for scale out of the read, and then you can also have a redundant server so that if this master goes down, you have the information here as well. Yes.
So, I was thinking about there. So switching over slave from one master to another master, how exactly is that done? I guess that kind of goes into like how do you set up a new master when slave is updated to the master archive data?
So let's say that you replicate from this guy to here, and this dies, and you want to replicate from him to that. So you check in the slave, you check what was the last position, what was the last thing I applied, and then you need to check in the log of the master for the same thing. Now, if you find the same thing as you just had here, then you do change master, and then you start slave and you start from here. There is one thing which is a little bit inconvenient with this, and that is that the positions of the log is the file name plus the byte position. And these can differ between these two guys. So you cannot only use exactly the same binlog name and the byte position and next to this. You cannot do that, but you have to find the right events to do. So that can be a little bit tricky. Yes?
Which of the two masters slave is really the main master of the backup?
So in this case, well, you could actually apply it here and replicate from this guy. Or you could apply it here.
Either of them, or you would
But normally you would, this one would be the active one, and you will apply here and replicate on it, and this one will only be passive. I think that's the most normal setup, because if this is the active one, you will have two loops before you get here. So you will have this active, you do squares here, you replicate here, but if this one dies, then you need to fail over these replications over to this guy. And also all clients need to fail over to this guy.
So now in this case, if the active master dies,
Yes.
then you would have to reconfigure the slave point to the second master.
Correct.
Yeah, but you can do that on the running slave. You don't have to stop.
Can you do that take master too?
Yes. So there are very few things you actually have to put into the configuration file, and we'll come to the way from those. One of them are the filters, which means that it's easier to add a filter by adding black hole anything instead of adding the filter, because then you have to early on. And the other one is actually turning on and off the binary log, or the logs and updates. You have to do that beforehand, which is why you have this configuration when you have to do it on. You have to have log-based updates and logs on both. But one of the channels, if you have a passive master, one of the channels will not be replicating. But in order to not have to bring anything down, you set up the channel.
Then there are other versions. You can have proxy master in the middle. But, I don't think that's very common. So this is describing the thing you do when you fail over from one master to a new master. That you can look in show state status, then you find the file and position, and then you need to go to the other server, and you need to find the corresponding event. And then you do change master and you do start share. But this thing of finding the corresponding position can be a bit tricky. Yes?
How do you do that when it may be that the original master is a moving program?
This is the information on the slave.
Yeah, you can't, well, the master you're failing over to, it has the information. So every slave, in the sense of every slave that replicates on the master has information about where it is compared on the position or not. So if you have a master that somebody can do, then you still have the information in the backup master. Yeah?
Here's the race condition where you have messages for event A on master is going to fail and event B on secondary master. Event B will come before event A, event A. They have to be replicated to event A.
Yes.
So if your first master fails, your slave, and your slave has the first event, and that's where it was currently, you flip over. Wouldn't you find the event A after event B, and that's event B is the slave?
Yes. If B is applied on the new master, and that happens before you have managed to replicate things, then yes, you do have this problem. You need to make sure that you are up to date as much as possible, that the relay log is applied before you connect the clients to the new master. And for this, you have this read-only, so you put the master into read-only mode so that they cannot connect, and then you make sure that the new master is up to the date, and then you allow them to connect.
In general, since this is asynchronous replication, any question saying, can we have race conditions? Yes. So it has a sense. You always have race conditions, so you have to keep track of this.
So we are actually at the time of a break, so let's keep that question for after the break. So we start the second half of the tutorial, and the tutorial ends at 12:30. So we have 1.5 hours. And we just discussing about how to do failovers of replication. So you had one master that went down and you fade over to another one. And either you try to automate it with some scripting, or the other solution, which is simpler, is to avoid this failover. And how do you do this? Well, there's different setups you can do. So you can have some kind of shared disk, and you have two masters, and then you have a. So this is a kind of standard configuration also. You have some virtual IP address, so your client connects to this, so it's kind of a load balancer. You have a heartbeat manager, which checks that these are always ongoing, that they are alive. And then this virtual IP address goes into one of them, and then it stores it on a shared disk. So if one of them fails, then they can fail over to this guy. And if you have a shared disk, then this master can read the binary log from this guy.
So the good thing about this, if you use something like DRD on your database array, can you hear me, by the way? No. Oh, I don't know. Do you hear me now? Better? Better? More? Fast? Okay. Yeah. So the good part about having, for instance, DRBD as a shared disk array is that the binary log positions are the same. The binary logs have different positions on the masters. If you have two different masters, if you're running this configuration and one casted, one active master, then you have the same binary log position. So when fail on the place, it will be automatic. You don't have to follow. If one of the masters crash, just the virtual IP will fail over to the other one, and your own place can keep running. No problem. So it's actually a very, very simple solution to solve the dual master problem at HA.
And another solution is to use a cluster as the primary server, because that has redundancy in itself. And then you can have MySQL servers connected to this, which you replicate to. And there are more complex scenarios. There's more complex scenarios where you can have virtual IP address in masters, and then you can have proxy masters, and then connect to slaves, and you have a shared disk area. Or you can have clusters, and they connect in this fashion to the slaves. So there are different versions to set up this replication. What's the order?
This is about sharding, actually. So suppose that you actually want to place you have the same setup as before, you have a friend table, and you have your message table. You could actually have them on separate masters and replicate out on those to other places to scale out properly. But there are a few problems. Usually when you're running a setup like this, you have messages and you have friends, you usually want to work with tables from both databases at the same time. Using, for instance, joins, so like multi-table selection and that kind of stuff. And you can't do that if you have this kind of sharding data. So you have to think about what you do. If you have an application level of reasoning, you have to think about how you use that. And there is something called federated tables, which actually is a table on my server here, which actually connects to another master. You can use that. So if you have a friend's table and a friend's database, you can on a message master, you can set up a federated table which will fetch data from the friend's server, and you can do your job. Now, federated isn't the fastest engine in the world, but it actually solves the job if you need to work behind this kind of setup. So it can be useful for occasional OLAP queries or in general when you do sometimes before, and you have a federated table and you do that. To use it continuously, well, you might have problems, but it's worth a try. It's easy to set up, it's easy to use, so check it out, it's a good idea. Yeah?
Is it possible to have something that's slave to different masters?
No, we don't have what we call multi-master. We don't have that kind of.
What you can do is that you can write a script that change the connection. So you would replicate 1 hour from one of the servers, and then you stop replication, and then you switch it over, and then you replicate it. So you can make some kind of switching like this in the script. But the automatic one, which we are developing, that is not ready yet.
There are some other tricks actually to replicate from several masters. We'll go through a few of them on the tricks section. But this is the classical one. We go through it all the time. You have a question?
It's federated on the slave or on the master?
In this case, it's when you want to do a join. So you want to do a join on, for instance, the message master. In that case, you have a federated table on the message master here, which connects to a table on the premise master. So you get the data off the table here, which is not federated. It will be conveyed to the message master, and you have to have a federated table on the message master with a connection to this one. Yes?
You do that place.
Yeah, you can do federated from any server to any other server.
More questions?
And here's how we do it. I mean, if you have a connection string, you just say, this is what I want to know. You have username, password, database, and it. Yeah?
Federated table from master, and then you get that too much slave.
Yes. So,
Can you repeat the question?
any change is done to the, or if you change stuff on the federated table, it will be written to the binary on the phone. Yes.
You don't need to put a federated table on the master.
Yes.
It's going to be created in save.
No, federated table is just a connection to an existing table on another server. Sorry? It will be, it's just a creation. So we have,
on the street, the average server, I will also use
yes.
that
Yes. So you have to make sure that you're not the binary wrong, or use both tables, or that you get the table saved on the playlist.
Okay, and this is another setup which Jeremy was explaining 2 years ago. And in this setup, the user can have applications and they're connected to slave. And if you do a write, you write everything on the active master. So this is in one place. So also if you connect through this one, on this side, you also connect to the same active master. And this one will be passive. So all the requests are sent to one active master, and this is passive. And then you replicate to these slaves, and you can do reads to these slaves. And then, if there's a failure, you make the other one active, and you replicate the changes in the opposite direction. So you can switch over between this. So the idea of this is that you have one master which is active, and the other one just you keep for being able to fail over.
That kind of architecture where the app is writing the master and then reading the slave, how is the app get designed so that it doesn't have to have itself read values before it's being gone around the loop?
Yes, you need to design the application in the correct way to do that. And one way is that the things you read might be more like a product catalog or something, but the things you write might be in order. And if you actually want to read the order you just placed, you want to read exactly the same information, then you can go to the master and read it on the master. So maybe some of the writes you should still do on the master if you want that information. But often, if you have, in many setups, the information you get from other users, for instance, it might not matter if that is a little bit off. But if you do something yourself, then you could cache it, and maybe you don't even have to read it again. So you already know that information. So one has to be a little bit, think about how to use this. And in Fire 1, we introduced row-based replication. And the traditional way to replicate stuff in MySQL is using statements. So the queries you put in SQL, the same queries are being replicated to the slave next to that. So we replicate the statements that are doing something. Well, it requires determinism because if you have a random number, if you generate a random number on the master and you replicate this over to the slave, you want exactly the same random number to be generated on the slave as well. So there are tricks in how we do replication. So we send over a seed to the random number, for instance. So when the slave is generating a random number, it will generate the same random number. So there are different ways to do so that this still is deterministic.
Yeah, the question.
Hi. Why would we use statement-based replication that seems to have inherent differences compared to row-based replication? I'm just trying to see the application usage of statement-based replication.
So is the question why we still use statement-based and we don't use only row-based?
Why did you make a choice to use statement-based replication?
So statement-based replication was done from the start, and the benefit of it is that, first of all, we replicate not only DML, we don't only replicate inserts and deletes and these things. We also replicate the create statements and the create views and all of these things. And if you want to replicate these things by using some kind of row-based mechanism, you could use this system tables and you replicate over, but it's actually quite hard to implement that. But if you're only concerned about replicating data, then row-based is often more easier to implement, and it's easier, and it's often quite good to use. But statement-based has also the benefit of, if you have a statement saying that update all rows, set x equal to x plus 1, then this is only one statement, but it can affect like 10,000 rows. So sometimes statement-based replication is more efficient because it tells the slave what it should calculate and not exactly all of the data that is affected.
So, like, trivial statements like create table, won't they be replicated in row-based replication? Is that what you're trying to say?
So the question was, how is create table replicated?
Yeah.
And create table is always replicated by statements, even in row-based replication mode. So even if you set it to replicate by row-based, the DDL is still replicated by statements in MySQL.
So on statement-based replication, all you're writing out is binary logs and statements, right? So that has very little load on the master. If you're doing row-based replication, wouldn't that increase the load on the master quite a bit? So if your scenario is you have a heavily used transactional system that's your master, and you just have a bunch of reporting databases that are your slaves, would you be better off doing statement-based replication to keep the load on the master?
It's very much, people often ask which one is more efficient, like statement-based or row-based replication. And I think that this is the question here too. And it depends so much on what kind of queries you have. If your queries are only like insert and update, and you only update one row with each query, then it sort of is the same thing. A row is actually a little bit smaller often. But if you have statements that update several rows, with this like x equals x plus 1 and it updates 10,000 rows, then statement base is more efficient. So it's very hard to say when so the customer scenarios I've looked at, it looks like it's almost the same. The efficiency don't matter so much between them. But it's very dependent on what kind of queries you execute.
I guess I'm still confused when you say efficiency. Are you talking about total load on the whole cluster? Or are you talking about how long it takes a master to do its job and write out the binary log and then go on to whatever after that?
Well, it's several things. It's one thing is to write the events to the binary log on the master. So that's the disk access, which takes some resources. So then the question is much on how big is the events, or how many are the events. And then on the slave you have, there's also that you need to execute it on the slave, and if you're row-based it can actually be a little bit quicker to execute it. But often the bound is sometimes the bound is on the execution of the slave. So sometimes it can be more efficient to use row-based than statement-based because it's quicker to execute on the slave. So it's very hard to say when it's more efficient to use one or the other. I would say we have done in 5.1 we make the mixed mode is the default, which is kind of statement-based application, but it has some protection. So that's the default mode, and if it works, then I think you should use that. And if you, for instance, use cluster, then you need to switch to row-based. And if you use very many stored procedures and out increments, then it might be better to use row-based. Because if you have really complex stored procedures, there might be cases where statement-based doesn't really replicate exactly the person. Yes?
So I mentioned for order increments, then statement-based would have issues.
If you use multiple order increments and you have a stored procedure which is calling itself, there's some very exotic cases where you use this when you will actually not get the right information. So if you use very complex things like that and you notice that it doesn't work, then switch to row-based application.
The general case, all increments, simple cases for total statement-based, or if you start to do strange things, complicated things, you might end up with tricky cases and statement-based, but row-based is just statement-based.
Okay. A row-based replication, instead of replicating the statements. So as you were saying, that when we replicate the statement, we replicate the statements as they are, but we also replicate a little bit extra information, like the server ID and the timestamp and a little bit of this information. But almost in principle, we replicate the statements. And in row-based replication, we replicate the actual changed row. So what was it before the change and what was it after the change. And this does not require an up-to-date slave because it's not calculating anything. It just takes the data and it puts it where it should be. So with the statements, it can be a statement which is dependent on the temporary table. So it's dependent on the context when you execute something. But row-based replication is something much lower level. It's just the data, so we just put it there. So it's not something which is calculated, which depends on other data, and this kind of things, which a statement often can do. And the row-based replication can handle also strange corner cases. And in mixed mode, we use statement for most of the cases, but when there are problems, then it automatically switches to row-based replication. And mixed mode is the quantifier. Row-based replication can handle more difficult statements and it's required by cluster. Statement-based is sometimes a smaller binary log when you have this updates that x equals x plus 1, for example. And also the binary log can be used for auditing, which is when if you use the MySQL binlog program, you can look in the binary log and you can see what was actually executed. So you see the actual statements that were done. But if you use row-based, it's much harder to see what was actually the statements being executed. You cannot see the statement being executed. You can figure out the data, but even that is it's tricky. So row-based replication features, the log is idempotent, which means that you can execute it several times. The log only has information about what should be put there. So if there already is a row in on the slave, it will just overwrite it. So you can actually execute the log twice. So if you execute the log twice, you get the same result as if you execute it once. And that is true for the data in the row-based replication.
So why do you have a primary key on the table? You don't have a primary key, you will get a frequency section.
And then statement events and row-based events can be mixed in a log. And the format of these are changed automatically. And you can even use different formats for different threads if you want to use different when you're executing.
Yeah, row-based replication is more or less a foundation for other things we can do. You can do a lot more with the row-based replication since you're actually replicating the actual data. So we can do things like we can have conflict detection and conflict resolution. To do that on statement-based replication is kind of fun because you have to parse the query, realize that kind of conflict. With row-based replication, you see that immediately. You have applying the same row, and you don't have the right field and the right image before, and that as well. You can also basically do fine-grained replication and filtering, and fine-grained filtering. So theoretically, you can implement this. You could filter based on a piece of primary key. You could filter based on the table, on the master side. You could based on basically any condition. If we don't have the software that could do this. So it's more powerful replication in this sense. Also, NDB cluster uses raw data inside, so it has to use raw data replication. Couldn't be done before because there were several problems associated with using segment-based replication for NDB. Raw-based, no problem. You can also use things like multi-channel replication, which is basically what we do with clusters. You use clusters. And you can do horizontal partitions, so you can take the rows and give them a path and send them in different channels or different databases if you want. So this is the foundation for things, very advanced things we can do in the future.
What do you mean by channel?
Sorry?
What do you mean by channel?
Channels. You can have two channels, two network cards, two networks connecting to slaves, or two masters, multi-master data. So that if the network breaks, it won't even backup as a network. So that's quite good. You can also use that to get throughput over every piece. So you have two completely different networks. Maybe technology and so
The common setup when you use cluster is that you have a cluster and it stores the data in different places and in different processes. And then you have two MySQL servers and they act as masters, both of them. And then you have a different cluster and you have two MySQL servers and they both are slaves. And then you set up a replication from this master to this slave and from this master to this slave. And then you have only one, so this is a replication channel. So you have only one active at a time. But in this case, you can fail over replication. So if one of these servers from the first one is breaking, then you can start the other replication. And there's support in cluster and replication for doing this, so that you can see what was the last thing that was replicated over, and then you can find, it's called in cluster, it's called epoch. So you can find the correct epoch to set up the second replication channel. So if you want to use cluster to get high availability, and you want to use replication to replicate it maybe to a different location or something like this, then you can use this multi-channel approach.
MySQL does not have auditing feature. How do I use this row-based and statement-based replication? I can add some hundreds of people issue some comment. I want to report it. I want to audit it.
Yes, in the binary log, if you use statement-based replication or statement-based logging, then you get the statement in the log. But it's not a full auditing. You don't know who did it and these things. So I think there is the general log now, and I think you get more of these auditing features in these logs.
According to the audit, some privilege people take in
Yes.
with people. And I want all what it is.
Yes. I think, I'm not fully aware, but I know that there has been a development project to improve on auditing. And we also changed this general log. And, so I will look up in the general log and see if you maybe you can find information there which you need.
One little piece of information using the binary log auditing. It does have, you only see the change to some. You don't see the attempts of doing changes that fail. So if you are executing a statement that fails, it will not be written to the binary log. And that could be interesting for auditing purposes, but the binary log don't care about it.
So the binary log would be a very, very simple auditing where you don't know who did it and you also don't get it. And filtering is done a little bit different for statement-based replication and row-based. So for statement-based replication, we filter on the statement. So we try to figure out what tables and what databases are used in this statement, and then we filter on that. And it might be that the statement is only reading something and it still gets filtered. So, and it's also based on current database. So if you say use database something, then that database is used when you filter the rest of the text, the rest of the statement. And if you compare this to row-based replication, we filter on the actual database table. So in row-based replication, you check actually what table did you modify. So those changes go away. And in row-based replication, we don't replicate temporary tables. We don't replicate, if you do an inter-select, we don't replicate anything about, we don't replicate where you selected. We only replicate what should be put into the table. So the filtering is only for the actual modification you do in row-based replication. And master filtering is on database only. And here you can do master filtering for individual tables, but we haven't implemented that, so it will actually not be on the slide. Okay. That's it. And if you want to have both statement and row format, this is just a trick. You can have the bin log, you replicate by statement, and then you replicate to the slave, and here you say that the slave should replicate by row instead. So you can have it in both formats.
You can, however, not go the other way around. If you are using row-based computation, you can't use statement-based on the text. So it goes to row-based and statement. Yeah, we have logging mode. This is how you We have, at this time, we have 3 modes. We have statement space mode, we have mixed mode, and we have row mode. Statement space mode is like the old replication technology using MySQL and before. Statement space, everything goes in a state. And we have mixed mode, which will switch to row-based replication when you have some unsafe statements. These statements, what is decided to be unsafe is based on a very rough analysis. So I mean, we don't want to spend cycles on analyzing every detail of every statement. But if we know something is unsafe, like we have a combination of all the entities that we know is there, then we switch to row-based. There are some other cases as well, but basically we require to switch to row-based when we have unsafe statements. And row-based, everything is row-based except PDL, of course, they are always statement-based. And you can set this on the fly. So you can set this for the input while you're running. You know the statement is unsafe, you put the row-based. When you have statement-based and you have non-safe statements, you will get a warning telling you that this is unsafe, but I'm going to execute it anyway. So sometimes the state is good anyway. Yeah. Then we have the formats, underlying formats. These are nodes. This is what you define. The format is what is actually being written to the line around. The variable for controlling that is called the node format. You can set it to 3 values: statement, row, or next. In statement space, you, as I said, you replicate names of statements. Next, you replicate row. Statement mostly is row sometimes, and row is row sometimes. And next is the
Any questions?
Is the mixed mode you say for all that, that's something that is really ready for production enterprises?
Sorry?
Was that ready enough for production?
Mixed mode?
The mixed mode. I'm using statement now, I guess.
Yeah. So mixed mode is the better version of statement-based. So it includes actually statement-based.
So it's not that big difference between mixed mode and statement mode. And Fire 1 now is release candidate, so it will very soon go into GA. So yes, it is version. And row-based is also used. In cluster, row-based is used all the time. Switching modes, you can switch the modes at runtime, and you can even do it inside the transaction. And there are a few cases where you cannot switch modes, and that is if the session has open temporary tables. And that is because in row-based replication, we don't replicate temporary tables. We only replicate changes. So if you created some temporary tables, we don't want to switch mode if you need to use this temporary table that you have created. So from inside the store function and triggers, you cannot change it, and if NDB is enabled, you cannot change the mode. But in most cases, you can even switch this mode as you feel like. Mixed mode was the default one, as we said. The save statements are usually logged in statement format. So we try to keep the statement format so that everything is always in the statement, so nothing is in the row-based. And mixed mode is just the improved version where we have problems, we have solved it in row-based replication. And also row-based replication is where we fix more bugs in row-based replication. It's easier to fix things in row-based replication than in statement-based replication. Unsafe statements are normally row format. Heuristic decision is what's unsafe, and these are the things which go into being row-based instead. Input delays, UUIDs, and statement updates more than one table on increment points. and some programs can run the user-defined variables.
Yeah, and this is how binary log looks, and you have here, you have a create statement. Statement has a query log element, which is the normal way to replicate stuff, the traditional way. You have the insert statement as this is a statement that has been replicated in statement mode, or mixed mode by now. It's a query statement as well. And then here we have the row elements, which make up the changes done to a table. In this case, we start with a table map, which helps you name everything you need to know about the table, and that's that to the single identifier, 16. And then if you have many rows, you just refer to that predefined table number. You don't see the rows here, but they are there. And we have 3 different elements. I think we can switch to the next one. That's the previous one.
So there's 3 different events. There's a write row event, which only has what should be written, and then you have delete, which is only the rows which should be removed, and there's update, which has what was the row before and what was the row after something changed. So change the row which looks like this into that. And the table map is the 4th event which belongs to row-based replication, and this event only maps this identifier to the table. And this was again some of the pros and cons of using statement-based logging. Well, the statement executed is loaded by the log, and the statement is logged after the statement has been executed. And the pros of this is that usually the smaller binary log, or usually I would say that they're actually the same, but they can be smaller binary logs. And the binary log can be used to, you can see what queries were executed, and also that you cannot handle partially executed statements, which can happen if you have a non-transactional engine. You execute some part, but not the other part of a being transaction. And you cannot handle non-deterministic data, except for where we have these seeds. And it does not work with all the engines, for instance.
Row looking for the actual change rows are executed. We are grouping all the rows together, so we have the row elements contain several rows. We need to configure the size of these elements, so if you want to have a lower latency, you can actually have smaller elements. Otherwise, you can have big, really big elements. You can have a non-deterministic statement. The database just listens to the binary log. So if you're talking about computations going on determinism and context, you can handle, for instance, in the F execution. When you have your own defined function, which you loaded, role-based replication handles that without a change. Not a problem. The bad thing is there is no easy way to actually see what's wrong. You have to be able to read text to see the actual evidence, and even that is not that simple. And it doesn't work with all engines. Black hole is not an issue actually, but there are engines that don't really work well with role-based replication. I don't recall exactly which one, 266 you, but we have some problem. Federated is possible. The good thing about role-based replication is that you actually can handle and filter monthly and table updates even from different databases. Here you see you have 2 maps, one T1, one T2, and you get 2 maps and you get 2 updates. And they are working with different tables. And then in every state it is marked with a flag saying that it's the end of the statement. For then you need to unlock tables on the slave. You can filter on this, and that's the good part. Since we have separated the events for the different tables, we can actually drop the events on the slave. You can't do that with database replication or then count database. But you have two different databases here, for instance. It doesn't work. Because you will either filter all statements or not. So we will have to check this out.
I have a question on that actually.
Yeah.
I want to understand that I can update, say, let's say I have two slaves, I could actually, let's say I have two tables in my master database, I can have a read slave, one for each table, and update through replication that way.
Yeah, you can do this quite a trace actually with all the replicate stuff. We have a bunch of these. We have some special cases. Create select functions. It's both the DDL and the DML. So what we do actually is that we replicate it as partially as a DDL and partially as a role. In this case, we internally, that's not the table now, so we forget that. We show create table basically internally to generate a description of the table. And then we actually write the role just up and then we write the statement at the end. Interesting thing about the create select statement is if it fails, the table is locked. So this statement actually behaves as if it was a transactional statement, even if you are manipulating non-transactional tables. This means it's not written to the binary log, it's a statement. And that goes to the yeah.
Now, in this case, if I have lots of rows in sequence, with the row base, fill up the binary log.
It will write all the rows to the binary log table. So that is an inherent feature or problem depending on your view. For full interpretation. If you are changing a lot of rows, then you will actually write a lot of rows to the binary log as well. If you don't do that, you will write more.
So can we filter this if we want to do that?
You can solve this.
Filter only the number of rows in P1 or like millions.
You mean filter on the log? Right now, we only have filtering on databases still. We have plans for allowing filtering on master based on the data that goes into the binary log, like for instance tables. But we don't have that right now.
But with the scripting support?
Yeah, we have scripting support on.
So that would be shown on the version tips. But that's it's a feature preview, so it's something very early.
Yeah.
Row-based update. How MySQL find the row usually?
So if you have an update, then you send the before image and the after image. What the row was before the change and what it was after. So it uses the before image to locate the row on the slave. Usually it uses primary key, and then it fetches kind of the row, and then it changes it to what it should be, and then it puts it in.
If the private key, for example, you have two tables, one table, but it's different in slave and master. So for example, you have one long big table, but in slave, maybe shorter.
Yes, if you get an update statement, an update event, and you cannot find this row, then we generate an error on that. Usually, didn't we push this flag so they can configure if it should be either positive or not?
Yeah, we have that. It's in Python. So you can actually find two based on.
So if you use the most strict mode, which is probably default, yes, then if you have an update event and you cannot locate this row, then you will get an error.
When taking a row on the slave best, you actually search the primary key, and then if you don't have a primary key, you use the best index you define. If you don't have a best index, then you remove everything. So if you want to have role-based replication to be efficient, you need to have a primary key. So you only need a primary key on the slave. Now, it doesn't make sense to have a primary key on the slave and not on the master, but you could potentially do this if for some reason you like.
Does it answer to your question?
So the performance could be slow.
If you don't have the primary key, then you can have an extremely bad performance on the package. I don't see many cases where you don't want to use a primary key. I think often you want to use a primary key just to be able to locate these things quickly. Do you have some question also? So the question is if we can specify a format based on table, and it's not possible today. And if you have a good user scenario also, it would be interesting. Because I get that, I hear that request sometimes, that people want it, but I don't really see exactly how it would be used. So if someone can send me an email saying that this is how I would use it, and it's actually useful for doing this thing, then it would be very interesting to know it. Lars at MySQL. Yes,
If I were to use MySQLbinlog on a binary log that contains what will get out of it?
The question was, if you use the MySQLbinlog program,
On a binary log that contains write row.
yes. So what does the MySQLbinlog program output if you have write row events? It outputs a new kind of SQL statement, which we call binlog. So it outputs binlog, and then it's a base64 encoding of the event. And we output this thing so that you can still use MySQLbinlog and execute the SQL you get from it. So this is a new SQL command so that you can still use the same way of taking this and treating it as SQL and modifying it to do what you want and then execute it from the server.
Yeah, we have some special cases actually. We have made database slightly different. We have concatenate and delete. If you use concatenate on table, that is the same as dropping the table and recreating. If you are using delete with no where condition, that is the same as deleting every single row in the table. So we have differences in behavior. Concave is logged in certain state mode because that deletes as if you drop the table and recreate it, while delete actually deletes each individual row in the row-based mode. So you log the row, you actually delete the row. So there is a difference. And the reason for this is that if you are making changes in several chains, slaves, perhaps a server or something like that, then you don't want to, if you concave at one place, you don't want to concave all tables necessarily, but you want to release the rows that you had on that server. So therefore you replicate just the deleted rows to the following server. So if you are adding rows to a later server in the chain, you will keep those rows. So the rows on the original master will be deleted. We have also the grant, revoke, and set password. All these statements that actually work with the MySQL database, they are replicated as statements instead of as rows. So anything that is a special statement for manipulating the MySQL database will be replicated in statement. If you, however, do delete an insert or an update of the MySQL table, that is replicated based on on the format here, so it's always. Yeah, and that's about it. These are the special cases we have right now. And then we have a long list of how service objects are open. Now that we have 3 different nodes. We'll go through them one by one. Some of them are really quick, others are slightly more complex. Database manipulation statements, they are replicated as statements. Table manipulations are replicated as statements as well, except for the DML statements. Insert, delete, update, they are replicated based on the format you showed. Views is actually just a select statement in fancy mode, so they are replicated. If you are changing something in a view, then you actually may change this underlying table, and then you replicate that change. If you are using row list, you replicate that change on the underlying table. The creator view is replicated as in statement form, and all of the DDL statements. But when you change the view, because I have not updated the view, then you actually replicate it in the system is quite handy. So it knows that, okay, I changed these rows, and you get those that one separate. You can see that here. I'm updating a table called living in, but in reality, the actual table change was a table called test name. When it comes to procedures, the actual create statement for the procedure is replicated in statement base. But here you have 4 stored procedures you need to define. For instance, that resolution based on you can either execute the stored procedure as if you were the definer or as if you were the reader user wrong. So therefore, there's an additional field you can add, which is called the definer. So if you write a create procedure, you get this one, which is basically say, I'm the one who is creating this. This is you that writes it. When it comes to the stored functions, we replicate create in a similar manner, like this. But the effects of executing stored functions is actually replicated based on the format virtual. So if you change inside the stored function or the stored procedure, you will replicate those changes instead of the actual for or the actual select state. Triggers, same thing. Create, alter, delete, create, alter, drop are replicated in statement form. But when you get to actually executing this trigger, you do that when you insert something into a table, for instance. When you do an insert into this thing, you probably discover that you actually change 2 tables. And that's because they have a trigger. I'm introducing the actual changes in row based. So of course, those changes generated by the trigger will be part of that statement as well. As you can see, this is one statement, of course I have the statement and flag long, and the table my value is always the key statement. Evans, create, alter, drop, we're using the statement space mode, but we don't want the evans to execute on the slave. Because eventually, when you create an event on the master, it will execute, it will make changes, you will replicate those changes. We don't want the evans to execute on the slave as well, which means we disable the evans when it arrives to the slave. So it will not execute on the slave. This is useful if you want to have the evans there, because you might switch roles on the slave to the master instead. Then you want the evans there, but you want them disabled until you actually decide this is one. And if you have any effects when you execute an event, it's replicated for roll format if you have roll format.
Any questions so far? Yeah, I will check out if we can hand it out, and then I will publish it somewhere. But I need to check out what we have, what the policy is. But it should be on the conference pages somewhere, or If you're interested in this presentation, of course, you can also send an email to lars@mysql.com, and I will answer if we can put it up or not. But if you can put it up, then we will put it up, yes. Any other questions? Yeah.
I have a general question, but can't get a slide.
No, you can take it on.
Okay, here's a quick question. You're using 4.0 introduction to master and slaves. You want to add another master for high availability. You want to add some more slaves for load balancing. Is there any problem with backwards compatibility? I mean, when you go ahead and start using 5 on our new servers, is there going to be any trouble with the old servers that were production using 4 and the new ones that are coming online with 5?
So the question is how to upgrade replication, I guess.
What I'm saying is, you don't want to have to upgrade our current servers because they're in production, they're running 4. We want to bring new master and or new slaves on, but they're going to be running 5. Is there any problem with that?
So when you upgrade, you should upgrade the slaves first. The slave is always more capable of knowing the old formats and stuff. So the slave is always better to handle that. But the master, if you have a new master and an old slave, then it's not necessarily so that the slave understands what the master is saying.
Got it. So if we wanted to add a second master for high availability, running 5, and we have another one running 4, we want to upgrade all the slaves to 5 first?
Yes.
Okay.
Yes.
But if you were just adding slaves to an old master, and you had no intention of adding another master, you can mix 4 or 5 on those slaves, and that's okay?
Yes, you should be able to use 4 or 5 differently on the slaves. We have had the principle for a long time that the slave should always be able to read all formats. And now from 6.0 and upwards, we are also wanting to do the opposite. So that you should, a master should always be able to communicate to, the new master should be able to send something to an older slave. But this is something we're working on. Okay. So implementation, how replication works. So we've already gone through a bit about the statements used and so on. So most of these things are what we have already talked about. So you have application, it connects to the MySQL server, and traditionally in the statement-based application, we take the statement and we put it into the binary log. And then the binary log is read through a thread here, which we call a dump thread, and it sends over the changes to the IO thread, which is putting the stuff in a relay log, which is only like a buffer on disk. The SQL thread is reading from this buffer and then applying it and putting it to different storage engines. So this storage engine here could be MyISAM and MongoDB. And so this is how statement-based replication goes. And then for a row-based replication, we catch the changes before they go to the storage engines, and we put these rows instead into the binary log. So this is showing statement-based applications. So this is from 4.0 to 5.0, and then in 5.1 we have the row-based replication. We catch the rows and we put those into the log instead. Any questions on these pictures? So there are three threads involved in the application. It's the IO thread, the SQL thread on the slave, and there's also a dump thread on reading it from the bin on the master.
How do you check the dump thread?
The dump thread is usually very anonymous, so you don't really see it. It's just whenever you make a connection, you get a connection thread, and that takes the role of being a dump thread. So it's like every connection to MySQL server, you get a thread for that connection. And in this case, this connection thread acts as a dump thread. More questions?
Okay, you basically have one dumper for behavioral replication, which communicates to, for instance, for status. And you get a list of what it is. The dumper you really do is just the correct position replication and then send to the world. So you have all the information about the dumper that is in the full master what's the name of that? Sorry?
Show master status?
Yeah, I think that only gives yeah, it is show master status. Sorry. So you see all the information about the dumper.
Where exactly is the dumper?
No, it's here.
Yes.
Is the relay binlog?
The relay binlog, this one. This is written by Ryan.
Okay, that's the I.
Yeah.
So in older versions before 4.0, there was only one thread, and the thread was reading directly and was just applying. But then we figured that it's more efficient to have two threads, one which is handling the transmission and one which is handling the applying of the information. And then this binlog here can be used to replicate further to another server. Yeah, so this is again the comparison between the row-based replication and database replication. So I think we said most of these things. And this goes into more details about the row-based event. That the table map event is what it means is that this table ID, so it just gives a number for a name in a way, a table name or a table definition. And then the write event just says that this row shall exist in the slave database. An update event is that this row shall be changed from what it was before to what it is afterwards. And the delete one is that this row should not exist in the slave database.
Worth noting here is that the table map evidence actually contains a complete version of the definition of the table, which means that it's able to check that the definition of the table matches on the slide what you had on the norm. So it's possible to do quite a better checking of stuff when you are using role-based replication compared to when you do statement-based replication. You can have different choices if you have columns with different same names at different times. In statement-based replication, you will get an error saying that this is not the correct type. And in some cases, you will actually have it work, or you have conversion from numbers to strings and that kind of stuff. Role-based replication will stop and say, no, I'm not replicating numbers to strings in table. So you have some extra checking actually make the role-based slightly safer than statement-based replication.
So in cluster application, so how cluster works is that you have different applications connected to MySQL servers, and then you have database nodes that store the information. So in this picture here, you have 10 different processes. So each box is a process. And these two have the same information, and these two have the same information. But you have partitioning, so you have half of the information is in this, and half of the information is in this. So this is a typical configuration of clustering. And then we use MySQL replication, what we've been talking about in this tutorial, to replicate from one cluster to another cluster. So it's kind of a global asynchronous replication. And then inside the cluster, there is a local synchronous replication with the two-phase connect. So using MySQL cluster together with replication, you can have both kind of applications going on at the same time. The cluster here is a storage engine in MySQL server. So it's a distributed storage engine. Any questions on this?
And if you want to take a snapshot of the master database, if you don't have a place, you basically have to shut down the master. There are some exceptions. But when you are having just a single master, you want to take a backup of that one, you can either shut it down and take a physical backup by copying the file. If you have in a DB, you can use ID backup, or you can use MySQL dump with a single transaction option, which is not on this transaction, which will then take a consistent snapshot of the data on the master. That will allow you to actually take a backup of the data without having to bring the server down. But MySQL dump takes a logical backup, and logical backups are in general takes much longer time to load into a new site. If you can take a physical backup instead, by just copying, that is much faster. In order to do this, you have to stop the master at a good point. So you need to take, do we have one time for this? Go back. You have to first take backup. You have to freeze the database so that you can get a point, a binlog position that the backup corresponds to. Then you can release the master again. Then you can create a play, load the data there, and you keep the master running. That's not a problem. When you start the play, you tell it to start from that position you recorded a long time ago. And then it will start from that position with the data that you had in the backup at that time. Yes? If you have single transaction, it's not broken. But if you are using other tables, not non-individual tables, then the tables are locked. So you would basically freeze the master. So if you can have a slave running somewhere, keeping track of the changes, that is usually that option if you for some reason need to clone that way. Because that's much easier. When you are sure you don't have to bring them on.
And if you use MySQL dump, you have options to do all these operations. You don't need to do more things. You can just use MySQL dump to do this.
Yeah, this is sometimes you have a problem. Master slave goes out soon. You get different data in different tables based on somebody maybe changed the slave or something like that. Then you can have table checksum actually compare the tables. You don't compare them row by row, you compare a hash instead. I prefer to say hashes. It's just table checksum. It's a number, a big number that represents all the data in the table. This is something that Max here describes in the distributed data problem. Several years something before, I don't think it was that myself at that moment. No, I
He started on
and then we have the thing, this is no longer called MySQL duplicate, it's called the master, M-A-A-C-K-I-T. And this is written by the Baron Ford, who has a bunch of useful tools to work with servers and replication. And one of them is actually with a table checksum, which can also give you some information about what rows are used. Yes?
Well, do you know what lock the table in those checkers?
Sorry?
Do you lock the table in those checkers?
Yes. I think it has to. I haven't tested it myself, but I don't think there's any option.
Well, I've been thinking about different versions of doing it, like having an accumulated checksum, but it's not it's something which we're thinking about implementing. It's a little bit tricky. Yeah.
Two things. It does lock the table and it does have options. But the only way that you can check the table is actually by comparing all the data on one and then comparing it on the other, and then making a smaller table of what data is changed, and then keep doing that again until you have a small subset of data. To actually do it in production where you want to check for a master and a slave, but at the same time it's really difficult because the table checking takes so long, and you have to shut down your master and your slave unless you have your master and switch over. So it's like it's pretty difficult.
That's the biggest problem is that you can't have slaves running when you actually do the check.
Right.
So you have changes going on all the time.
Right, so you have to have two, in order to really do that, you have to consistently do them. And when you do them, you have to switch your application point to a third master slave cell. Rather, third slave that would be using your application.
Well, I agree it's a tricky problem to... So if I understood it correctly, you say it's very hard to implement it because you need to keep some smaller tables and it's a tricky problem.
Well, the way that Bergen did it was that, to have a true checksum, you have to check all of the tables at the point in time. And to do that, you have to lock both of the tables. And so, if you have a master and a slave, and you want to lock both of the tables, well then, you don't really have any place to write or read your data. So, the only way to really have a checksum without having a lot of the tables is by looking at all the rows on the master to a certain limit, and then all the rows on the slave to a certain limit. And of course, there's going to be changes, but then you take those changes and you look again, and there will be less changes, and then you look again and you look again, and then you can see it's some mistake and get replicated.
It's tricky, and we've been thinking about different solutions to do things like this, but we haven't really settled on any solution. I think you can use some kind of running checksum and do some other tricks also to basically make it more efficient. But yeah, there's implementation things.
The idea we have for actually implementing data ourselves is to allow the storage engine to provide a checksum which you can do incrementally, and therefore you can keep it available all the time. Then you write it to the binary log, and then you check it at that point, because then you have a point in time where you did the check. So if you write it to the binary log, you actually can be able to check the table on the fly. And see, does it match? Doesn't stop. If it does, okay, keep running. So that's the idea we have, but we haven't implemented it.
So delayed replication. So this is one version to do this, and we will show another implementation of this on replication tricks and tips and on the Bergen. So we have implemented a contributed patch for doing delayed replication in the code. And then there's different tools for managing virtual IP addresses. The Linux A-shaped project, the hard fitting, that's often used. And there are like some clusters, HTTP service card and things like this. Hardware load balancer, use that. So this is some tools one can use together to manage the virtual IP addresses and also hard fitting.
Yes. You can have a shared storage and have SAM, something similar. There's an implementation for the we have a guide here one that has a presentation from Linux. That's nice technology. You have two, basically you have a remote device which shares, which is replicated. You can have two of them going at the same time. Yeah?
Is it possible to have master and slave on different operating systems? Same
Uh,
MySQL version with different operating systems?
It shall be possible. We know there are some problems with some OS systems, some that doesn't work well together, but that's fine. It shall work. There's nothing. We have designed it so that we should be able to run it in different operating systems. There is no difference.
The only thing I know about which is a problem is the table names. If you have big letters and things. Because the file names on Windows and Linux treat big letters in different ways. So there's a bug report somewhere about that. So if you name your table, if you have all the tables in big letters or something like this, then it's no problem. So there's some problem with that. That's the only one I know of. Otherwise, it should work perfectly correctly with the operating system.
And SQL storage, you can use network cache, hardware science storage, area network, or of course hardware network effect storage, like that. One thing on the previous slide, there's actually a quite cool project for managing virtual IP addresses called Bergen. I don't remember who actually wrote it, but it's working now. It's software technique for managing virtual IP addresses, which is not high availability in the traditional sense. It's still high availability, but they are using a new kind of technology or relatively new kind of technology called group communication systems to actually implement a virtual IP high availability solution. So how do you get that one? What's it called now? Whack-a-mole.
Whack-a-mole?
Whack-a-mole.
You spell that?
Whack-a-mole. Like a game. So you can have, if you have data centers far apart in the world, then you need to have security because I would trust anything sent over the internet. You don't want to use it either. So you can use SSL for replication. It's not a problem. It's built in. You can just sign certificates instead of these, like normally. And replication will go through SSL instead. Yeah. You have S-tunnel, for instance, which is used to tunnel data to all the internet over a secure tunnel. And you also have various kinds of hardware solutions for doing this. But you should consider the case that you actually want to transfer data to data. Because one of the things you are using asynchronous replication for is actually to have you have to transfer site one down to earthquakes or whatever. So you need to have a long-haul network. And if you have a two-phase link from New York to London, it doesn't work. So you have to have asynchronous replication. Instead, you just hold it over in case you have a ticket. And then you don't want the main master to actually stop. Myself is actually using having this kind of setup, or had it, I don't know how it is right now. He had it set up where you replicate each direction from Stockholm to Norway. So we switch direction, fine, and one is master and the other one is master at the time, depending on the time frame. But there are many ways actually to use it, but you need to consider the case that you have to have the data. That means SSL or any other of the secure solutions.
So this kind of concludes the tutorial. There are some references. We have the MySQL manual, of course, where you can read about replication and cluster replication. There are forums for discussion of replication. And then there are the replication tricks and tips session and the bot. And so replication tricks and tips will be like half of it will be different tricks to use replication as it is now, and half of it will be about new future development and new things that we're doing. and we have feature close. So we will present this on this presentation. And then on the bottom of the further session, this is the 7:30, so it's not probably then on the bottom we will show scripting support, how you can write your own scripts to control how your application behaves. And we will show also the CD synchronous replication, which was written by Mark Callahan from Google to start, and we have changed that patch. And we will also discuss synchronous replication solutions, which are pluggable into MySQL, and this is also new development. So there is quite a lot of new development and discussion about where we should take replication in the future, what features are needed and new things. And it's more, the both is more of an open discussion, but we will still make some presentations on the both as well. So I think we can take a few minutes for questions or general questions. Things we didn't cover in the tutorial. Yeah.
If the primary log is state, what happens if state